Hello. Whoa, it's recording. Let's go. All right. So today we're doing a different problem called Bitonic Array Maximum. Bitonic, whatever, something like that. Um, yeah, the problem statement is find the maximum value in a given Bitonic array. An array is considered bitonic if it is monotonically increasing and then monotonically decreasing. Monotonically increasing or decreasing means that for any index I in the array sub I does not equal to array sub I plus 1. So in this example, we see this first part is monotonically increasing because it's always increasing, and this last part is monotonically decreasing because it keeps decreasing. So yeah, this is another question that is whatchamacallit, a modified binary search. And so with that being said, let us put the answers here first. So we're just trying to find the largest element in the array. So it's 12, 8, 12, whoops, I don't want to press enter there, and 10. And so without further ado, let us get into actually coding the solution. So we still want to do binary search, so we're going to do a left, right is equal to 0 and length of array minus 1 because we need our bounds, right? And so one of the two, okay, so we have two major differences, or I guess three major differences in how we find our solution in this binary search problem. The first one is being while left is less than right. We don't actually want it to be equal because if the moment we're equal, we don't have we know that like what do you call it? Actually, no, that's not even we don't want it to actually be equal because then we'll like end up hitting well, we might. So if we do the while loop again, while left and right are equal to each other, we could potentially we'll end up screwing up our answer. We just want the answer where left and right are equal to each other. So yeah, that's one of the major differences. The other difference is, I'll explain it when I get there actually. So mid is equal to left plus right minus left, and then floor division 2. For anyone that is probably just looking at this problem and hasn't seen anything else that I've done regarding modified binary search, the reason why we do this is because it prevents us from overflowing the number of bits that we can use in order to represent our number. Because if we did left plus right, then floor division, that could potentially overflow. In this case, the largest number is just right. So if we would have overflowed, we would have overflowed like earlier on. And so now we need to write the code for determining which, if we want to go left or right in our binary search. And so this is another difference that we have. So if array mid is greater than, whoops, I don't want to change input language, sorry. If array mid is greater than array mid plus 1, that means we're in the monotonically decreasing area. And so, okay, let me comment that actually. Monotonically decreasing part of the array. And so if we're there, we want to go to the left because we want to find the largest value, right? And so since we don't know what part we're in of the monotonically decreasing part, we just want to move to the left, and whenever we're in the monotonically increasing part, we want to move to the right, and eventually we'll converge onto the maximum number in the array. So here we want to do right is actually equal to mid, because even though this number is greater than this, the number to the right, it's possible that the number that we're currently looking at is actually the largest number in the array, right? So we can only make our right equal to mid. We can't do mid minus 1, because what if the number we're currently looking at is the largest number, right? So else, I guess we don't have to, this just stands for the array mid is less than array mid plus 1, because it's it does not equal either, right? And it has to be increasing or decreasing, so we never have to worry about the less than or equal, or like where they're both equal to each other, right? So this would be monotonically increasing part of the array, right? And so here we can do left equals mid plus 1, because if the number that we're currently looking at is not the greatest value, because we know the one to the right is a greater value, we can do mid plus 1. Because remember, we want our solution to actually be, we'll break out of this while loop once left is equal to right, right? And so we want to find the value using the left and right, I guess, pointers in a sense. And so eventually, once they're equal to each other, we'll just do return array left or right. It doesn't really matter. They're both equal to each other anyways. So with that being said, let us run the Python file, and we get our expected solution 12, because that's the largest number, 8, which is the largest number, 12, which is also the largest number, and 10, which is also the largest number. So yeah, with that being said, thank you for watching.